Okay, this video is for flex day number 2 during quarter 3. This is going to focus on exponent rules and specifically some errors that you might want to avoid or might run into, and also how to deal with variables in your exponents. So the first thing that I want to point out is when you're combining or canceling exponents, the base has to be exactly the same. So a common error we might run into is maybe I have something like x to the 7th plus 5 cubed in a numerator. And then maybe I have just x to the 7th times, like, let's just say, just some other random factor, 3x plus 2, okay? So what some people might try to do here is cancel this x to the 7th with this x to the 7th. That's not okay, so don't copy that down. We're not going to be able to cancel that because this base is x plus 7 to the 5th, whereas this base is x to the 7th. So the bases are not exactly the same, so we can't do any kind of exponent simplification with these two pieces. The bases have to be exactly the same. So what we would need for some cancellation would need to be something like x to the 7th plus 5 cubed over maybe 3x plus 2 times x to the 7th plus 5 squared. Okay, now we have 2 of these in the denominator and 3 of these in the numerator, so we can cancel these 2, and we can cancel 2 of them up here, which will leave us with 1. So now we have x plus 7 to the 5th, x to the 7th plus 5 to the 1st. Okay, so you cannot do any kind of combination or cancellation unless the bases are exactly the same. Okay, need same exact base. Okay, so this kind of brings us to another point that when you have multiple pieces within this your factor, so if we have x cubed plus 3x, okay, squared, what some people like to do, and this is not true, is make this x to the 6th plus 3x squared, basically distributing this 2 to both pieces. But you know that we cannot do this, because what does x cubed plus 3x squared mean? Okay, this means x cubed plus 3x times x cubed plus 3x, right? So what we have to do is we have to multiply each piece by each piece, which you may remember this as is like foiling, multiplying the first piece together, and then the outside piece, first piece, outside pieces, and then inside pieces, and then last pieces. Right? We have to multiply each piece by every other piece. So we get x cubed times x cubed plus x cubed plus times 3x plus x cubed or 3x times x cubed times 3x again. Okay, that's our inside pieces. Okay, plus, and then finally we would do 3x times 3x, right? First, outside, inside, last. And that is not going to be the same as what we got over here, okay? So do not make this error of trying to distribute your exponent to both of your pieces when there's addition or subtraction involved, okay? Now, to make your life easier, one thing that you will not want to do is start multiplying stuff out before looking to see if there's anything that cancels. So let's say I have something like 3x times x plus 7 squared, and then we'll put that over 5 times x plus 7. Okay, so the thing is, when you see x plus 7 squared, you're almost conditioned to think, oh, I better multiply that out, and then maybe I should distribute this 3x, and maybe I should distribute this 5 here. What I should do first is see if I have any matching factors that I can cancel, and in this case I do. I have this x plus 7 down here, and I have this x plus 7 squared up here. Okay, so there's 1 down here, there's 2 up here, so I can cancel one of these with one of these up here and make this x plus 7 to the first, right? This is super helpful when this made our simplification much easier than if we had tried to multiply everything out first and then tried to cancel, right? Cancel, see if you can cancel anything first before trying to simplify anything else, okay? So next I want to talk about variable exponents, which will come up in calculus a decent amount when you start looking at series. So let's say we have something like x plus 9 to the nth power, and then let's say we have, we'll say 3x minus 7, and we're going to actually put this to the n plus first power. And then if we divide that by x plus 9 times 3x minus 7, okay, well, you see we have our matching bases, our x plus 9 bases, and we have our matching bases, our 3x minus 7 bases, okay? So remember, our quotient rule says that when we have the same base on top and bottom, we can subtract the exponents, right? So how this is going to simplify is this is going to give us x plus 9 raised to the n minus 1 power, because this is the first power here, so it's the n minus 1 power. Okay, what about this other piece? We have 3x minus 7, okay? Well, this is an n plus first power minus the first power down here, which is just going to drop us down to an n, right? So now we have x plus 9 to the n minus 1 over 3x minus 7 to the n. Okay, let's try another one real quick. So if I have 5x plus 9 to the nth power, and then I have 3x plus 7 to the k power. And then let's put this over 5x plus 9 squared times 3x plus 7 to the k. All right, so what do we get? Well, 5x plus 9 to the n over 5x plus 9 squared, we're going to get n minus 2 when we subtract our exponents at 5x plus 9 to the n minus 2. And then what do we get up here? Well, we have an exponent of k minus another exponent of k, which is going to give us 0. So that's going to give us 3x plus 7 to the 0 power, which, oh yeah, that's just 1, right? Anything to the 0 power is just 1, and we could have just canceled this from the beginning because it's the exact same piece, 3x plus 7 to the k over 3x plus 7 to the k. All right, so here's our final answer, just 5x plus 9 to the n minus 2. So it's going to be the same idea with our other rules. If I have x to the n times x squared, that's just going to be x to the n plus 2. And you should always do a simplification like that to make your expression more simple. All right, if I have x plus 5 to the n plus 1, and then I multiply by x plus 5 squared, okay, well then we have to add those exponents together, and that's going to give us x plus 5 to the n plus 3, right? N plus 1 plus 2 more is going to give us n plus 3, okay? And then finally, obviously, if we have something like x to the n, and then we raise that to the 5 power, that's going to give us x to the 5n, because we're just going to multiply our exponents, right? If I have x plus 9 to the third power, and then I raise that whole thing to the n, that's just going to give me x plus 9 to the 3n.